All right, we are now focusing in on agricultural waste. Most of agricultural waste is organic matter, which you really don't think of being pollution because it's like, we'll feed the birds, throw it out the window. But it is a form of pollution. It's just not littering, I suppose. Um, and here's a picture of organic waste that comes from this cow farm. I don't know what you call a cow farm. Um, Dairy farm, I suppose, dairy farm. And then here's a list of examples. You have dead leaves and algae, sewage, animal feedlot, food processing. Um, and so organic matter, though, is broken down from bacteria. And so it ends up in the water source, and then the bacteria um, decomposes it. And if you have enough oxygen, then you have aerobic decomposition. And if you don't have enough oxygen, then it's anaerobic. Anaerobic decomposition stinks really bad because it produces H2S, H2S, hydrosulfuric acid. That's it. Um, which smells like rotten eggs. And so it's kind of like, I don't know, like almost in a way like a dirty decomposition. And if you have a lot of oxygen, then it's kind of cleaner. So colder water dissolves oxygen better. And so that's kind of if you think of like a swamp and how it's like super kind of like maybe stinky and icky and the water's still, it's anaerobic, um, kind of like a dirty thing versus like a clean like mountain lake, which has the fresh water running through it. It's a little colder environment, nice clean waters. That's your aerobic decomposition. Because you have these organic wastes are just going to be in the water from, leaves and stuff naturally. So it's really oxygen that makes it like that mountain lake and the swamp. Um, so this is the oxygen demand curve. So as the bacteria decomposes things, it's using up all the oxygen. And if you don't have a fresh oxygen source, like, a stream coming into the lake or anything, it gets depleted. And so here's an example of here's the level of oxygen, like going down this distance from this inlet. Let's say this is a stream. You have the sewage coming in. And so as that's decomposing and the bacteria is using the oxygen, you have a lack of oxygen here. And then the further away you get from that, your oxygen comes back up. Um, all these animals that need oxygen to live, you don't find them here. The lack of oxygen is going to either kill them or they're going to move downstream where there's more oxygen. You get not all life disappears. I mean, you do get some, these little worms and things, but you're not really getting those larger oxygen dependent animals. Um, and this is, let's see, so with the flow of oxygen, the cold water, that's why people put like fountains and like ponds and lakes and stuff is to help aerate it. Sorry, I meant to say that earlier and forgot. Let me see. All right, yeah. So the more organic matter you have, the more decomposition you have, the more oxygen it uses up, and without an oxygen source, it's going to become depleted in oxygen. When that happens, it's called eutrophication. And then you get some really high nutrient levels here, specifically phosphates and nitrates. And plants like algae love these nutrients. So algae will grow. And so that sounds fine, like, okay, that's natural, and yes, but that's also these algal blooms are what you hear of that like kills people, like, like the algae in the lake, or even it happened at the coast of California just recently too. All these seals were dying because of the algal blooms. Like so a lot of these algae will produce like toxic fumes. So it's not a very good thing to have. And then it's kind of like a positive feedback loop that as you're depleting the oxygen in the waters here, you're killing a lot of the plants and stuff, and they die. And then when they die, they start decomposing, which then uses more oxygen, and then more things die. And so it's hard to kind of stop this trend. And not just from natural sources. A lot of these and these like big algal blooms you hear of that are killing everything in like these random lakes and whatnot, are actually runoff from fertilizers and farming practices. So like all of our synthetic fertilizers have a lot of nitrates and uh, phosphates in them. Um, oh, and potash, um, which does the same thing. And so if you put too much into crop or you're not filtering that out by other means, then it's going to run off into the water. And we're at whatever lake or pond that all of that's running off into, eventually will you'll get so much nitrogen and phosphates in there, or nitrates and phosphate, that these algal blooms will happen. Um, so then here it's listing some proper application of fertilizers plus crop rotation strategies may help reduce these problems. And here's just some images showing like where that's more problematic in the country. Now anaerobic digestion, I guess it's not all bad. We have found uses for it. That is, we take advantage of this concept and we engineer biogas from it. And so if you collect the organic waste and create this eutrophic environment or this anaerobic environment, then you can get the biogas. And so you can see that turning that into a fuel source seems kind of smart. And you can see that trend has been increasing in doing that, using it as a fuel source. Um, we also have sediment pollution, and this is not only related to agriculture. I mean, it can be construction and all sorts of things. We've already kind of talked about that. And you don't really think of it as being pollution either because, yeah, I mean, it's just dirt. It's not even man-made. The problem is if a stream isn't supposed to have, all of this sediment in it, it's hard on the wildlife that lives there. If they live swimming around in this nice, clean, crystal clear water, and all of a sudden a bunch of dirt gets dropped in, you're messing with like the amount of sunlight the plants are getting. Hard for maybe the animals to find food because now it's murky. So it does impact wildlife. Um, I'm exposed to wind and rain, so I'm skimming the little notes here. Fine grained sediments choke waterways and reduce sunlight penetration, finish animal and plant. Yeah, I just said that. And solutions require planning such as contour plowing, terracing, and installing windbreaks and settling ponds, which we've pretty much, I think, covered all of these. Maybe not settling pond. I don't remember if we talked about that previously or not. Here's just an example of a settling pond where um, you just kind of you stop the currents, and with that lack of velocity in the water, then it really fine things settle to the bottom, and then you kind of just let it like skim off the top, is what a settling pond is. Pesticides come with agriculture as well. We have herbicides and insecticides, and all that soaks into the ground and ends up in our water. It's really kind of disturbing to think about. Many of the chemicals used in producing them are toxic and persistent. Some of those forever chemicals that even though we've stopped using them for decades, they're still around. I guess it's a good thing we stopped because we're not increasing the concentration, but still like it hasn't just, bacteria and organisms haven't eaten those up like they do other things. And then here's a spring applications of agricultural runoff, it spikes. So here's a chart that shows that throughout the year. And you can see as they get ready for farming in the spring, we have a lot more of these found in our water sources. And then the solutions, growing variety of non-chemical insect reduction strategies are finding increasing acceptance. Sometimes the introduced method itself becomes a problem. Like if you want to like introduce another bug that eats your pest, and then the new bug can become the pest, right? Although the book talked about they're like sterilizing some of these like the predator bugs. And so then they go out and eat the problem bugs, but then they can't breed. And so they just die off naturally, which is kind of smart. And then we have, of course, our genetically modified, where it's like resistance to some of these pests, but then people don't necessarily love eating genetically modified foods. They don't feel like it's safe. I don't know enough about them to say yes or no if it is or not. But it hasn't really taken off because consumers aren't buying them. Here's just some charts showing the concentration. Or no, this is percentage of samples and agricultural and urban and stream water and fish tissues and in the bed sediment being like the grains that have fallen to the bed of the lake or the river or whatever they're testing and seeing how many. So if they took 100 samples, and that means about right here about 30 samples had these atrazine and diethylat. I don't know these chemicals in them. And that is it for agricultural pollution.